You can say that the remote future, well, is that the end? Or can you imagine that the remote future extends into something else? What about the Big Bang? Maybe you can imagine that extends backwards. Why the Big Bang was so special was because it is the conformal continuation of something. The model I'm putting forward, a crazy model, but nevertheless, it seems to make a lot of sense. You stretch out the Big Bang, and then it becomes the continuation of the remote future of a previous eon.
What existed before the Big Bang? Roger Penrose is a well-known British mathematician who believes he has found a definite answer to this question. In the 1960s, Penrose suggested theories indicating that our universe experiences an unending cycle of birth, evolution, and end. Despite his theories, Penrose, who is now in his 90s, rejects the idea of a multiverse. In this video, we delve into the evidence supporting the idea that our present universe could have come from a previous cosmos and explore how black holes provide clues to potential alien existence. Textbooks commonly start their explanations of the universe with the concept of the Big Bang. This event is believed to have given rise to the entirety of our cosmos, originating from an initial singularity. This mathematical and physical validation of the Big Bang has been long-standing. In essence, the beginning of our universe can be summarized as follows. A tiny point housing all potential in an undefined state deviated from its balance due to an initial push, now recognized as the Big Bang. Although the idea of a resounding bang is debatable, as sound requires particles and receptors for transmission, the initial moment may have happened silently, without sound transmission or noise in the vacuum of space. The exact occurrence remains unclear. In the realm of quantum physics, it is currently hypothesized that a state of quantum fluctuation existed before the Big Bang, existing in perfect balance. This aligns with the concept of nothing in the context of physics and mathematics. Within this state, tangible and observable matter is absent. Yet nothing is an absolute void, but rather a repository of potential through information and energy in a state of complete rest. Normally, particles emerge within this quantum vacuum, interact, cancel each other out, and disappear. Neither matter nor forces are created. Yet, a mysterious push prompts a particle pair to move away from its neutral state. This pivotal moment signifies the start of creation, disrupting the previously harmonious balance and leading to dissolution. Suddenly, all stored potential unfolds from a tiny point, giving birth to the universe. However, at this point, matter is absent, replaced by a scorching primitive energy soup at a temperature of 1,000,000 degrees. So far, we are familiar with this story, yet the question remains: what triggered the initial moment? Where did the quantum vacuum come from? And what existed before the birth of our universe? The cyclic universe concept proposed by Roger Penrose challenges the idea that our cosmos came from nothingness. As early as his entry into academia, Penrose held the belief that our universe's origin was more complex. By the time he earned his doctorate in algebraic geometry from the University of Cambridge in 1957, the fundamental principles of the Big Bang theory had been around for about 3 decades. The scientific community had concluded that our known cosmos likely came from an initial point, a phenomenon deduced through observations of cosmic background radiation. These initial electromagnetic signals of the young cosmos have traveled across the universe and remain detectable through radio telescopes. The realization of this once theoretical concept became a reality with the advent of the Wilkinson microwave anisotropy probe, which around the year 2000 generated a detailed image map of cosmic background radiation. Between 2001 and 2010, the probe orbited among the Earth, Moon, and Sun, providing a comprehensive map of the familiar cosmos and many new insights into its structure and evolutionary journey. In 2010, Penrose presented a study revealing circular concentric irregularities within this background radiation. Through mathematical precision, Penrose showed that these irregularities might be evidence of pre-Big Bang activities, specifically remnants of collisions involving supermassive black holes. This discovery allowed Penrose to seamlessly integrate a crucial piece into his cyclic universe paradigm. Among experts, this framework has come to be known as conformal cyclic cosmology, CCC. CCC proposes a sequence of individual universes within the dimension of time. In Penrose's model, a single cosmos arises, matures, deteriorates, and then rejuvenates through a new Big Bang. It is important to note that CCC cosmology does not propose the simultaneous existence of multiple parallel universes and differs from the idea of a multiverse. Instead, according to Penrose, universes occur in phases and cycles, undergoing expansion from a singularity, followed by ongoing expansion until gravitational forces cause contraction. This final phase is called the Big Crunch, a phenomenon where expansion slows down and mass-induced pressure increases, resulting in the collapse of the material realm due to its gravitational pull. According to Penrose's framework, as a cosmos reaches the end of its life, supermassive black holes absorb all matter, breaking it down into photon configurations within themselves. These cosmic giants become so massive that space-time collapses under their gravity. The Big Contraction, or Big Crunch, is one of three potential outcomes. The Big Freeze suggests that the universe will eventually freeze as its energy resources run out. The third scenario, the Big Rip, theorizes that after continued expansion, the universe will tear apart like aged, inflexible fabric. What sets apart these scenarios, Big Freeze, Big Rip, and Big Crunch, is the aftermath, or what happens in the cosmos beyond the endpoint. Here, a parallel can be drawn to the existential question about humanity's continuation, conclusion, and potential persistence in this realm. Interestingly, Penrose's theories resemble Far Eastern wisdom and religious beliefs, suggesting an eternal cycle encompassing birth, existence, death, and rebirth, a phenomenon not limited to humans and souls, but also applies to stars and entire universes. Mathematically and empirically, only the Big Crunch strongly supports this cyclic model. After the cosmic collapse, a phase of temporary rest and perfect balance follows, seemingly without existence. From this foundation of quantum fluctuations, or the zero point, a new cosmos emerges driven by its initial momentum. The Big Freeze, on the other hand, lacks a definitive narrative. If the universe's energies decline, a lifeless cosmos persists indefinitely, devoid of vitality. An exception could occur if unknown external forces intervene to awaken the universe from its dormancy, infusing it with renewed vitality. Similarly, the Big Rip introduces similar uncertainties. If the universe tears apart, fractures in the fabric of space-time create chaos and complexities that hinder reorganization. Mathematically, this scenario doesn't lead to an unquestionable continuation or innovative progress. According to the Big Rip theory, the universe would remain like an abandoned vehicle on the side of the road, slowly decaying. Now let's discuss Roger Penrose's ideas about the geometry of the cosmos. Roger Penrose is a respected mathematician and physicist who holds a significant position in the scientific field, although his recognition may not be as extensive as the late Stephen Hawking. Penrose and Hawking have been scientific collaborators who wrote many papers together. Their collective work focused on the study of singularities in harmony with Einstein's theory of relativity. Singularities occurring before the Big Bang or within black holes are mathematical concepts awaiting empirical measurement. However, Penrose and Hawking managed to computationally prove the existence of singularities on multiple occasions, leading to the Penrose and Hawking singularity theorem. Beyond his mathematical achievements, Penrose showed an interest in geometry, conceiving the perplexing Penrose triangle, an imaginable shape defying physical construction. This impossible shape, also known as the tribar, emerged in the 1950s, inspiring artists like M.C. Escher and his famous works, such as The Waterfall and Belvedere. For Penrose, the essence of the universe stems from geometric sequences and linear patterns, similar to the tribar and Escher's art, accommodating intriguing impossibilities. He refers to a cosmic segment or lifespan as an eon, connecting these cycles through a structural framework. In Penrose's model, the blueprint of a new universe lies latent within the culmination of its predecessor, and the mathematical framework governing a dying cosmos inevitably leads to the birth of a new universe. This transfer of information from old to new universes illustrates Penrose's insight. He demonstrated that, like collapsing black holes, our universe's cosmic background radiation holds insights into the nature of the preceding cosmos. However, there's a caveat to Penrose's theories. They depend on the universe slowing down in its twilight phase. Currently, our cosmos is perceived to be in its middle age, showing no signs of deceleration. In reality, the universe's expansion is accelerating. Although this acceleration might eventually stop, certainty eludes us for now. Furthermore, Penrose puts forth a compelling idea about extracting energy from black holes, a thought-provoking concept with theoretical validity. Penrose mathematically supports this proposition, though he acknowledges that its practical realization would require advanced civilizations. If such cosmic power stations exist, their detection from Earth could manifest as minor anomalies at black hole event horizons. Yet this discovery wouldn't automatically lead to extraterrestrial contact, leaving a sense of mixed emotions. The existing technological gap prevents meaningful communication with such entities. The nearest black hole is located 1,000 light-years away, and any signal sent would likely travel vast distances, potentially outlasting human existence. We're interested to hear your thoughts on Roger Penrose's cosmological framework. Do you imagine a succession of universes, each followed by another? How do you feel about the idea of extraterrestrial energy generation at black holes? Your insights are welcome in the comments section.